Hello everyone and welcome back to this amazing channel. This is Abhinav. In this particular video, we'll discuss about the solution to the problems of Starters 123. We will basically discuss about these five problems of this particular contest, which is maximize adjacent sum, minimum and maximum, minimum and maximum 2, check adjacent sum, yet another Alice and Bob game. This is the next problem, trial of the conqueror. This I'm trying. So if like mostly probably I will solve, like upload this problem after this video, but for this particular video I will discuss about these five problems, right? So let's discuss all the problems one by one. So the very first problem is maximize adjacent sum. Here you are given with the array and you have to find the sum of elements of an array in such a way that you have to find sum of pairs ai plus 1. Okay. And by doing this, you have to maximize the value of this. Means you have to rearrange the array in such a way that this value is maximized. Right. That is what you have to do. So how you can achieve this thing, right? So for example, your array is like this. Let's say your array is like this. Okay. Now what this said? This said is f of a or f of array is equal to summation of I is equal to 1 to n minus 1 ai plus 1. Right. That is what they are saying. Basically what you do is you have to find sum of every pair, every adjacent element, and then you have to find the overall sum of that. Okay, let me give you an example. What basically this means? So this basically means is you will find first sum of this 5 plus 8, 5 plus 8, then 8 plus 1, then 1 plus 7, then 7 plus 3, then 3 plus 4, then 4 plus 6. And then you have to find the sum of overall all the numbers. That is what you have to do. So if you will see, if you will add these all the things, you will see that for all the numbers in between, for all these numbers, they all are present twice in the final sum, right? But the boundary elements are present only once. Okay, and what we want? We basically want to maximize this value. If we want to maximize this value, what we can do is we will try to make our minimum values in the boundary. Why? Because boundary elements are added just once and middle elements are added twice. So we will try that the maximum elements of our array should be added twice so that we can get a maximum sum. So what we will do is we will basically just rearrange the array in such a way that the first two minimum elements of the array, the two minimum elements of the array should be at the boundary. So basically 1 and 3 are the minimum elements. So we will keep 1 and 3 at the boundary and remaining all the elements, whatever they are, we will keep in the middle, so that they all are added twice and they are added once, and that will give you the answer, right? So if you will see the code, what I have done here is I have simply taken the input of the number and the vector. I have sorted the vector. So for the first two minimum elements, I have simply adding them once in the answer because they can be just considered once because they are in the boundary. And for all the other maximum element, the last n minus 1 elements, I am taking twice of that because they will contribute twice in the final sum. And then I am printing the answer. Okay. That is what we will do here. I hope that you have got this particular problem. You will get the link of my submission in the description. Also, if you have any doubt, you can join the Telegram or you can ask it out in the comment section, right? Let's move forward. So next we do have this problem, which is minimum and maximum one. So actually we have two parts of this problem. Okay, we will discuss both the parts. So the very first part is that we are having a array, and again what we will do, we have to deal with the adjacent pairs, right? Pairs of adjacent elements. We will take the minimum of pairs of adjacent elements and find the sum of all. And by doing this, we want the minimum sum. We have to rearrange the array in such a way that we get a minimum sum at the last. Okay. So for example, and also one more thing, This A is actually permutation of length n. So this array A is the permutation of length n, right? So let's see how we can do it. So for example, n is 6. So our A is basically 1, 2, 3, 4, 5, 6. Now what you have to find? Your value of f of A is actually summation of I is equal to 1 to n minus 1. Not n minus 1, n actually. It's a circular array that you are taking. It's a circular array, okay? Means basically for the last element, this first element is the adjacent to it. It's a circular array, right? And you have to find the minimum of all the adjacent elements, and then you have to add them. For example, first pair is 1 comma 2, then 2 comma 3, then 3 comma 4, then 4 comma 5, then 5 comma 6, and then this 6 comma 1 is also a pair. Now you will take minimum of from all. So from this minimum is 1, 2, 3, 4, 5, and then 1. 6 comma 1 minimum is 1. And then you will find the sum of this all. Right. And for this the sum will be 16. But you have to rearrange the thing in such a way that you get the very, very minimum sum, the minimum possible sum. Let me tell you how we can do it. See, when n is 6, you have basically 6 numbers. What you can do is you can rearrange in such a way that first you have a minimum number, then maximum number, then 2, then 5, then 4, then 3. In this way, if you will see, from the first pair, the minimum come will be 1. From the second pair, it will be 2. From here again, it will be 2. From here, it will be, sorry, I did one wrong thing. Will be, see, it will be like this. So we have initially something like this, right? So first we will take 1, then 6, then 2, then 5, then 3, then 4. So from the first pair 1 comma 6, minimum will be 1, plus see, from here minimum will be 1, from here it will be 2, from here also it will be 2, from here it will be 3, here it will be 3, and here for these both it will be 1. So if you will see, 1 is present 2 times, 2 is present 2 times, 3 is present 2 times. So basically every number from 1 to n by 2 is present twice. Am I right? And then simply find the sum. So you'll find the sum of all the numbers from 1 to n by 2 and you will twice it. But this is only for the when n is even. So what I can say, I will say that I can divide the part into two parts, two cases. So if n is even, let's say 6, we taken the case, right? Or let's take 8 also. Let's take for 8. So it will be, initially it is like this, right? But we will arrange it in such a way. First 1, then 8, then 2, then 7, then 3, then 6, then 4, then 5. So from here it will be 1, then 2, again 2. We have to take minimum, right? 3, 3, 4, 4, and then from this both 1. So you can see all the numbers from 1 to n by 2, which is 1 to 4, are present twice. Just find the sum. You see what I'm doing here in the solution. I'm first taking value of n. Okay, I'm first taking input of n. Then I'm finding the value of n by 2. Why I'm doing this n plus 1 by 2? That's for the odd case. I'm finding value of n by 2. Then we have to find sum of all the elements from 1 to n by 2. So for finding sum of elements from 1 to n, formula is n into n plus 1 by 2. And we have to also do twice of it. So when we will do twice of it, ultimately formula will be n into n plus 1. That is what I am doing. I am simply saying my answer is n into n plus 1. I have said here n, take it as answer. So I first divided n by 2 because we have to just take from 1 to n by 2, and then my answer is this. Okay. Now what I did, yeah. Now what I did, for the odd case thing will be different. So let's say n is equal to 5 for the odd case. For odd case, what will happen is first there will be 1, then 5, then 2, then 4. But this extra 3 will come. So in this case, it will be 1, 2, 2, 3, and then 1. So in this case also, you will see from 1 to n by 2, and actually not just n by 2, the seal division of it means from 1 to 3 every number is coming twice except the last number. So we will do the same, we will do this only, but at the last we will subtract this last number, which is actually n plus 1 by 2, the seal value of n by 2. So if the value of n is odd, the original n that I'm storing in nn, if it is odd, we are subtracting its value from. That is the basic question. If you have any doubt, you can ask that to me in the Telegram channel or in the description. Right? Great. Let's move forward to the next problem. Next, we have the second part of this question. In the second part, the only difference is here we have to find max. That was min, this is max. For max, the thing will be a little bit different. See, when you have to find the max value, see, overall we have to get minimum only. Overall, we want minimum only. But we have to take the maximum of the number. See, for example, n is 8. So your permutation is 1, 2, 3, 4, 5, 6, 7, 8. Now, when you are taking the maximum of the adjacent numbers and you want overall sum as minimum, right? So, for example, if you will take pair as 1 comma 8, your output will be 8. Your output will be 8. And when you will take your pair as 7 comma 8, here also your output will be 8, because you have to take the maximum of the pair. तो यहाँ पे भी देखो 8 आ रहा है, यहाँ पे भी 8, यहाँ पे भी, तो बेसिकली इन द पेयर द ग्रेटर नंबर विल बी टेकन. तो हम क्या ट्राई करेंगे कि अगर हम ग्रेटर नंबर ही ले रहे हैं तो उसके साथ वाला जो नंबर हो पेयर का वो भी एक बड़ा नंबर हो, so that we can eliminate that. For example, when I'm taking pair as 7 comma 8, output is 8, that is fine, but I am also eliminating 7. या वो 7 को हम कहीं और नहीं लेंगे, जब यहाँ पे लेंगे तो हम 7 ले रहे हैं, यहाँ पे 6 ले रहे हैं, then 5, then 4, then 3, and then 2. So ultimately, if we will see, this original permutation from 1 to n will be the answer. This is the permutation that will give you the minimum value. This is the only permutation that will give you the minimum value. No other permutation can give. Right? Because you are doing like this. So you will simply keep the permutation as it is. Just find the maximum of all the adjacent pair. And if you will see, the adjacent is basically all the numbers from 2 to 8. So 1 nahi hai, from 2 to 8. What I did here also, I first calculated the sum of all the natural numbers from 1 to n, which is n into n plus 1 by 2. And at the last, I subtracted 1 from it. I subtracted 1 from it because this 1 is not there. Ye 1 starting ka nahi aayega. Now I'm adding a extra n here. Why this extra n actually? Because we have to consider this pair also. And this pair will always give you, right? So that extra n. This is the logic for this minimum and maximum too, right? Amazing, amazing. Now let's move forward to the next problem. If you have still, if you guys have any doubt, please feel free to comment down your doubts, and also join Telegram for post contest discussion. Okay, cool. Now let's move forward. Next is check adjacent sum. So this problem is also again the same, where you have to take the adjacent numbers. Here we don't have that what we say, circular array. Here we just going up to n minus 1. Here actually they are saying that you have an array, okay, and so this is actually a number where I have used a lot of things. I'm not sure if this problem can be done in a better way, right? Maybe it can be done in a better way, right? So basically here you have to you are given with the array, right? And f of a is defined as sum of that pairs only, that what we discussed here. So we discussed, right, this f of a, where we were finding the summation of adjacent pair sum, right? That is what is given to here. But here what they're asking is that yeah, there are q queries, right? And in each query they will give you a value x. Now they are asking that is there any rearrangement of the array that gives you the value of fa as x, right? So here we are finding that what's the maximum value of fa possible. Here we were finding what is the maximum value of fa possible. But here they are asking that if is there any rearrangement such that we can get the fa value as x. If it is possible, print it. If it is not possible, print -1. Right? That's the case. See, guys, if you will, if you remember what we did here, or let me again tell you the intention behind that problem. The problem was that if we rearrange the array in any order, let's say like this, the observation was when we take the pairs, let's say 5 comma 3, 5 plus 3, then 3 plus 1, then 1 plus 8, then 8 plus 2, then 2 plus 4. The observation was that for all the numbers, so all the numbers are considered twice except the boundary elements. तो सारे numbers दो बार ऐड हो रहे हैं हमारे, देखो इस आंसर में, but the boundary elements are just added once, right? So that is the basic problem that we can get. तो बेसिकली अगर हम ऐसा करें कि हम इन सारे नंबर्स को दो बार कंसिडर कर लें, लेट्स से 4 को भी दो बार, 5 को भी दो बार, वी आर कंसिडरिंग एवरी नंबर ट्वाइस. So this is the total sum that we can get. Total sum will be, let me count the sum, it will be 10, 20, 23, 46. So 46 is the total sum when we are adding all the numbers of the array twice to 46. But we cannot get sum 46, never, because there will be at least two elements, and not at least, there will be exactly two elements that will be present at the boundary, और वो दोनों एलिमेंट सिर्फ एक बार ऐड होंगे, but we have added them twice. So what we can do is we can check any two elements from this array and we can subtract their value from the total. कि हाँ भाई, we have considered these two elements in the boundary, so consider them just once. So because they are added twice, subtract them. So this basically means is कि okay, total 46 है, but let's say if we are considering 3 and 2 at the boundary, then total will be 41. Let's say if we are considering 5 and 8 at the boundary, so total will be 33. If we are considering 1 and 4 at the boundary, then total will be 41. Yeah, exactly. We can get the whole total and then just choose two numbers that you wanted to keep in the boundary. And because they are boundary elements, they have to just start at once, subtract them one time from the total sum. Right. So if they are giving you a value x and they are asking you that whether this x is possible or not, whether that x is possible. For example, our total sum is 46. Okay. And I'm giving you my x as, let's say, 36. 36. Okay. So you will subtract this 36 from 46. You will say 10. Basically, what this 10 signifies? So basically, you want to rearrange the elements of the array in such a way you get the total sum as 36. That is what you want. When you are considering all the elements twice, the whole sum was 46, but you want 36. Means you have to take two boundary elements such that their sum is 10. Is it possible? Yes, it is possible. Because if you will take 2 and 8 as the boundary element, so they will subtract 10. Because they are boundary elements, they will be just considered once. So 2 and 8 will be subtracted from 46 and you can get 36. It is possible. Same, let's say if x is 40. Can you get 40? Yes, you can get 40. How? 46 minus 40 is 6. And yes, you can get two numbers with 6. 1,5 is also there, 2,4 is also there. So there are multiple options for it. But let's say I'm asking you, let's say for example, let me see which is not possible. Let's say I'm saying 29. Let's say I'm saying x is 29. Means you want to rearrange the elements in such a way that the final value of f is 29. It is not possible because the total sum is 46 when we are considering every element twice. If we subtract 29 from it will be 17. But there is no pair having, so it's basically a two pair problem, two sum problem of lead code. If you remember the two sum problem, that's all. हमें ये फाइंड करना है कि इस एरे में से क्या कोई दो नंबर्स हैं जिनका सम 17 है. आर देयर टू नंबर्स इन द एरे whose sum is 17? It's a simple two sum problem that you have to find, right? तो अब सीधे सीधे हमने पहले हर नंबर को 2 बार कंसिडर कर लिया, उसका टोटल निकाल लिया कि अगर हर नंबर 2 बार लेंगे टोटल कितना आएगा। ठीक है, अब बिकॉज जो बाउंड्री एलिमेंट्स है वो सिर्फ एक बार ही लेंगे, तो हमने 2 बाउंड्री एलिमेंट चूज किया और उसको हम इस टोटल से सब्ट्रैक्ट कर सकते हैं। दैट इज व्हाट वी आर डूइंग। देखो इन द कोड व्हाट आई डिड, I first taken the vector and I found the sum of the vector and then made it twice. Consider every element twice. Okay. Now here I am doing some other stuff. You can also use some other method. I first taken a frequency array where I use the store the frequency of every element. Then I taken a map. In this map actually I am storing that for a particular sum is the pair possible or not. So for example, for if there's a number vi and vj, so they can sum up to a value vi plus vj. And I'm also storing which pair is giving you that value because we will use it later. Now for each query, we'll get a x, that this sum is what we want. First, we'll subtract total minus x. This is the number. So if there is any pair which has this value, means we can get the answer. Otherwise, we cannot get the answer. Now, we'll first find mp.find x, that if there is any pair which contains their sum as x, if it exists, we are doing something. If does not exist, simply output -1. It's not possible. Now let's see if it exists, then what we are doing. If it exists, then what we do, we have to print that particular pattern. तो उस पैटर्न में हम क्या करेंगे, द नंबर दैट वी हैव सब्ट्रैक्टेड मीन्स बेसिकली द टू नंबर्स विच आर गिविंग यू द सम एज x, that we have to just print once and also in the boundary, and remaining numbers we have to print in between. So you can see here we are also storing the two numbers which are giving you this sum. So I'm simply extracting those two numbers. I'm also decreasing their frequency. Why I'm decreasing their frequency? Because we have to print them in the boundary. So I've decreased their frequency. I first printed the first number in the boundary. Then in middle, I printed the other numbers of the array using the map. And in the last, in the boundary, I printed the second number. So in this way, first number is printed, then remaining numbers are printed, then second number is printed as a boundary element. And then for the next query, I have again increased the value of that so that they can be used for the next query. Right. So that is what we are doing. I am doing this question in a complex way. I did whatever I got at the time of contest. If you can solve it in a better way, you guys can like comment it down if you have solved this question in a better way. Or also if you have any doubt, any suggestions, please do comment it out. Okay? Great. That was the problem check adjacent sum. Let's discuss about the last problem for today's video, which is yet another Alice Bob game. This was also a very interesting problem. So the problem says that Alice and Bob are playing a game, right? And basically the thing is that there are some n piles of stone, right? And Alice can take at most A stones from this pile, and Bob can take at most B stones from the pile. Okay. But minimum of they have to take one. So basically they can take stones from 1 to A and 1 to B. They cannot take stones less than 1 or more than A. Bob cannot take stones less than 1 and more than B. That is what they have to do. Right. Now, what basically we have to do is that we have to see the person who will pick the last stone will be the winner. Who winner hoga. So let's see how, first of all, how many conditions. So this is a game theory problem, you know. There will be multiple conditions that I have made. It's a really easy problem. Not easy, but implementation wise, you can see I have just added some condition. But thinking of that condition is a little bit different. I can understand. Difficult, okay. Very first case. Let's discuss the very first case. When total number of piles are less than A. Basically, for a see, Alice starts the game and then alternately both plays. For example, initially there are 5 piles, 5 stones in the pile. There are 5 stones. Initially there are 5 stones. And let's say A is greater than or equal to 5. Let's say A is 7. So what? Simply Alice will play the game and he will take all the 5 stones and he will win the game because Alice is starting the game. Elias has the first chance, right? So it's very easy for Elias. What C will do, Elias will simply, because number of stones present are less than or equal to A, and Elias can take, भाई Elias 1 से लेके A तक के stones ले सकता है, और अगर जो stones हैं वो 1 से A के बीच में है, तो Elias सारे stone ले लेगा and she will win. That's all. The very first case I mentioned is if n is less than equal to A, Elias will take all the stones and Elias will win. Definitely Elias will win. Right? Cool. Now, when it's not the case, अब देखते हैं next case. Next case is, let's say for example n is 20, A is 7, B is 10. अब देखो यहाँ पे क्या होगा. यहाँ पे what Bob will do, the allies is having stones less. So allies is having less stones. Basically, allies can take less stones. Allies can take just 7 stones, but Bob can take 10 stones. See, here always Bob will win. So whoever will have greater value will win always. How? Let me tell you. मान लो 20 stones है. Let's say Bob ने 5 stone ले लिए, 15 बचे. अब let's say, oh sorry, Eli's taken 5 stones, 15 are left. Let's say Bob taken 2 stones, 13 are left. Let's say Eli's taken uh, 2 stones, 11 are left. Let's say Bob taken 1 stone, 10 are left. Then Eli's taken, let's say, all the 7 stones, 3 are left. Then Bob will win. Bob will win. See, how always Bob will win in this case? See, Bob is having, Bob can take 10 stones at once, right? So Bob will just play one by one, one by one. He will just wait for the chance when there are just 10 stones remaining. He will just wait for that chance. And whenever there are 10 stones or 9 stones or 7 or 8 stones remaining, he will just get all the stones. Because Elias has to wait for 7 stones. तो वो 7 stones करने नहीं देगा ना Bob. Bob will take all the stones whenever 10 stones are remaining. For example, कि 20 stones are right. Let's say Elias taken all the stones. Now 13 remaining. Bob will just take once. Bob is playing very cool. Bob will just take once. Now let's say up now Elias can, let's say now Elias also take one. Let's say Bob also takes one. Up 10 stones bache. So in this 10 stones, again chances of Elias. Let's say Elias will take one. And now Bob will finish the game. Take all the 9 stones. So Bob will always have an extra hand because he can take more number of stones. Elias has to wait to reach number of stones to 7. But until she will wait, Bob can take it because Bob's value is greater. And same vice versa, if value of Elias is greater, let's say like this, then always Elias will win. Okay, I hope that you getting it. मैंने बोला आप 15 स्टोन लोगे, मैं 10 स्टोन लूंगा, ठीक है. अब भाई मैं वेट करूंगा जब तक वहां 10 स्टोन हो जाए ताकि मैं एक साथ सारे ले लूं. जीतूंगा तभी जब एक साथ सारे ले लूंगा. पर आप बोलोगे भाई जब तक वो तुम 10 स्टोन का वेट करोगे मैं पहले ले लूंगा ना. वो मैं पहले 15 मेरे पास मैं ज़्यादा ले सकता हूँ. आई विल टेक इट फर्स्ट, राइट. So simple case is if A is greater than B, Elias will win. If B is greater than A, Bob will win. Now thing comes, the else case comes when A and B both are equal. So when A and B both are equal, then it's a case, it's a matter, right? देखो वहां पे क्या होगा, वहां पे क्या होगा when A and B both are equal. See, so basically let's say there are n stones. A and B both are equal, right? A and B both are equal. Elias and Bob both can take equal number of stones. For example, let's say A is 5. A is 5, B is also 5, they are equal, right? And let's say N is 10. Now, what Elias will try? Elias will try कि Bob के पास जब stones जाएं, Elias will try when Bob will take the stone, that stone should be 6. Why? Because जब वो stone 6 होंगे, which is A plus 1. When there will be 6 stone with Bob, when there will be 6 stone with Bob, which is A plus 1, Bob has to definitely take 1 stone. Because minimum 1 has to take 1 stone. तो Bob को एक stone तो लेना ही पड़ेगा. Why? Exactly. You cannot skip. You have to at least take one stone. So Bob will take one stone, and then remaining will be five. Then Alice will win because a5 tha. And the same thing happens with Alice. Then Bob will win. So if a person is having n plus one stones, not n plus one, a plus one stones, so opposite person will win. So basically, one will try to make the opposite person having n plus one stone. And because Alice is having the first chance, Alice will definitely do that. कि जो बॉब के पास जो स्टोन्स हैं वो n प्लस वन हो और सॉरी a प्लस वन हो या a प्लस वन का मल्टीपल हो. Either Bob has a plus one stones or a plus one multiple stones. But if initially Alice is itself having a plus one multiple stone, then Alice will lose. So I'm simply checking if n modulus a plus one is equal to zero means initially अगर एलाइस के पास ही a plus one mod a plus one के मल्टीपल के स्टोन है तो वो हार जाएगा. क्यों? मान लो a5 था. ठीक है, तो a5 था, a plus one is 6. Let's say Alice has 24 stone. Let's say Alice taken 3. तो बॉब क्या करे? बॉब ट्राई करे. अब कितने बचे? 21 बचे. बॉब ट्राई करेगा, इसके पास 6 के मल्टीपल थे, 6 के मल्टीपल रखो, वो भी 3 ले लेगा, कहेगा तो 18 बचे. अब लेट्स से एलाइस ने पूरे 6 ले लिए. लेट्स से सॉरी 6 ने 5 ले लिए. ए 5 है तो ये 1 ले लेगा. अभी भी इसके पास 12 बचे. अब इसने कहा मैं भाई 4 लूंगा, ये 2 ले लेगा, क्या 6 बचे. अब वो फंस गया. अब 6 बचे. अब वो कुछ 1 ले, 2 ले, 5 ले, पूरे 5 भी ले लेगा, 1 बचेगा और बॉब जीत जाएगा. तो whoever will have a plus 1 multiple of stones will lose. If initially Alice will have that, Alice will lose. But initially अगर stones a plus 1 के multiple नहीं है, तो because Alice will play the chance 1, वो इतने stones ले लेगा कि जब बॉब के पास stones जाएं तो वो a plus 1 के multiple में हो. तो बाकी सारे cases में Alice ही जीतेगा. But in the initial case, initial stones देख के बॉब जीतेगा अगर वो a plus 1 के multiple में. So I hope that you got this. It's actually a very complex logic that I thought of. If you have any doubt, you can ask it in the comment section, or you can also join a Telegram. So guys, we have discussed these first 5 problems of this Codechef Starters 123, right? Uh, I hope that you have got the complete understanding of this all. Uh, if you have any doubt, you can again join Telegram and comment down. Please comment helpful if this video is helpful for you all. Thank you. Please subscribe to the channel. Thanks a lot. Bye.